Tutorial, we're going to use Ladybug and we're going to figure out certain things. For example, how to obtain a heat map like this, which helps you locate and orient your building or orient your mass. This is called solar radiation. And also to get things like a sun path, amongst other things. So, first of all, if you've not installed Ladybug, the easiest is to type www.pollination.solutions, go to product, go to the Rhino plugin, you'll open this, download for free, and then install it. And that's the easiest way. If that doesn't work, we can figure out some workaround, but that's the easiest way. And once you have it here, I'm going to open Grasshopper, and it's going to take some time. But what I have here is that I have a context model, and you can see that I have three buildings, and then a base, and then your actual building. That I have a context here. Your context can differ. Yeah, I have some buildings, and I have this main building that I want to get the solar radiation for, and I'll get back to this workflow in a bit. But just I want to take a moment and introduce you to something known as CityWeft, which I recently found out about. Go to citywef.com and go for try for free and log in from your uh, Google account, your college account, and then it basically opens a map, and you can go for any city in the world, any place in the world, and then I figured out that okay, like I'll take a place in India which has high rises, and I type Mumbai, and then I got this data, and when I go for export for free, I'll have a lot of options here. Okay, so this is Rhino 8, which is the default one, but I can go down and go for Rhino 7 since I'm using Rhino 7. So once I export this, I can download this, and from here I can import this here, right? So there are some limitations in the amount of the area that you can sort of download, but it can give you accurate city and your building built data at your disposal very easily. Now coming back to Ladybug, uh, the basic idea is that you have something known as a weather file or a .epw file, which is basically recorded at several lakhs of weather stations across the world. That will give you a lot of data like your your temperature, your humidity, your radiation, your wind speed, all of that, and that you will feed. I mean, you download it from the internet and you'll feed it into something known as a matrix, which is a solver which will do a lot of calculations, which will also feed in your building and your context, amongst other things. Right now, this part is what part of the year, which is hours of the year. What period of the year do you want the analysis for? Do you want it for several months? Do you want it for one day, some months, all throughout the year? That you can optionally feed it into the matrix. If you do not feed it, it will calculate for all the hours of the year. Okay, so that is one thing. You can always get the Sunpath, which is a very small thing. From a particular day of the year, you want the location of the sun, or a particular month of the year, you want the points where the sun is, the angle where the sun is. So if you can have these two things, you can get the sun path. If you have these two things, you can also feed it into the matrix, which will calculate your solar radiation, which will look somewhat like this. So now let's get to the actual uh, code. Okay, now if you've downloaded Ladybug successfully, it should appear somewhat like here. I have icons here, but you might show L or LB on the top of your Grasshopper tab. I'll go to this, and there are a lot of tabs here, a lot of options. Uh, let's first locate where are these particular component or components are located within these tabs. Okay, so first is we'll have to download a weather file, or we have to locate it online. I'm going to be doing it online. So first import download weather and import that EPW. So this looks pretty scary, but I'm going to download it. That is, provide a URL, and I'm going to have imported from that URL. So nothing, I'll just connect this to this, and it's empty right now, but that is the first thing. Now just space it out a bit. get the matrix, you can go to visualize data, and there is cumulative sky matrix. Now, benefit sky matrix is, it gives you results in terms of plus and minus, or it calculates in terms of plus and minus, which can be really confusing. That what are the good shades and what are the bad shades, or what is the benefit and what is the harm and all that. Anyway, cumulative, it gives you a very simple added result. So I'm going to go to Ladybug cumulative sky matrix under visualize data, right? And it's going to load up. If any of these components are turning red for no reason, that means you have not installed Ladybug properly. But by default, they should be just orange. Sometimes you can see that loading a component can take time, but this is the benefit. This is the cumulative sky matrix under visualize. Now, Sunpath again is somewhere here. Ladybug Sunpath. I'm going to put it here. Hours of the year is going to be under analyze, analysis period, right? Hoist or period is analysis period. It gives you what, from what month to what month, what day to what day, what hour to what hour do you want this analysis. This is completely optional. If you do not do this, it will compute for the entire year, which is useless, especially for solar radiation, because it's also going to add up night, and it's going to add up a bunch of zeros, and still going to take computation time. Right, so we do not want this, but we'll get to that in a bit. And incident radiation comes under analyze, and this is incident radiation. Okay, now this is so that if you've gotten the gist of this, is the most basic code that you need, apart from small other inputs. Okay, now getting the URL. Now, URL is a website. So the easiest way is go to Google, type Ladybug weather file, and it'll open an EPW map, which looks like this. You can always Google anything. As I said, I was looking for Mumbai. You can see all of these are the weather stations across the world. Okay, India alone has hundreds of weather stations, and you can zoom into your city, or you can always search for your city, and it'll look for, let's say, Mumbai itself has 3 weather stations. I can download, right click anywhere, any one of this, and if I click here, I can say copy. And once that is done, I can go back, open a panel, which is double click and double quote, and paste it here. Now, this is what a weather URL looks like. It's sort of a zip file, but it shows that Maharashtra, Mumbai, International Airport, all of that. So this is where it's going to be borrowing from. Make sure you're connected to the internet. And I'll just feed it here. And now you'll see everything will turn white. That means it gets the data online, and it gets all of these things from that weather file. Now, moving ahead, I'm going to simply feed this, but let me hold on for a bit. Let's get the Sunpath. Now, for Sunpath, it requires a couple of things. Now, all of these things might be extremely scary, but let's see what it requires for the Sunpath. Now, north. Now, let's consider that if I have the x-axis as the east and the y-axis as the north. So I'm going to put unit y, and I'm going to feed it here. Now it asks for location. Let's go from top to bottom. I can feed location to location. Okay, and you will see the Sunpath immediately pop up. But it's going to be showing for the entire year. Let's look at the hottest months. Let's say March. So I'm going to be putting the months work from 1 to 12. So 3 is March, and let's say all the way till, let's say, June. So 7, that's the end month. And this hoist, or hours of the year, are these numbers associated. Every number means one particular hour of the year. So I'll put this hoist to hoist. It's pretty standard, and you can see all the suns popping up, right, at all these hours. You can always say that I want it only at 1 a.m., which is 1300 hours railway time. So I'll put start hour, and I'll also put end hour. So you can see that's pretty much at the top. The only thing is it's still off, and your model is somewhat here. No problem. There is center point. I'll put a point container, right click, and put it somewhere here. And then put this here. It kind of comes here, and finally scale. So I can enlarge this. So kind of get that idea of where the sun is going to be, and it helps you sort of locate and get an idea that okay, at 1 o'clock from March to July, this is where the sun is going to be at each of the um, whatever 120 days or 160 days, right? Anyway, so this is what it is regarding Sunpath, and we'll move ahead to actually get the solar radiation. Now for solar radiation, it again asks for a north. I'll feed the same north here. It asks for a location. I'm going to feed location here. This is the matrix. It's not doing anything explicitly. It's just doing an internal calculation. Direct radiation, find direct radiation, direct normal radiation here. Diffuse radiation here, and Hoyce. The moment it turns white means it's functioning automatically. Again, as I said, Hoyce is not compulsory. It is calculating for the entire year. But if I feed the Hoyce, which I did, which is from 1 o'clock but March to July, I can feed the Hoyce here and get a more specific data. Again, nothing's happening, but we move ahead to the crux of this game, which is incident radiation. Now, incident radiation asks for again from the top sky matrix. So I take sky matrix here, geometry and context. Now, this might be a polysurface, this might be a mesh, depending on where you're getting your model from or massing from. So I'm just putting geometry, which is just a larger umbrella. I'm going to make two, Control C, Control V. The first geometry, I'm going to place the actual building and place it into geometry. The second one, I'm going to be placing the context. Okay, and I'll put it here. And finally, there is a couple of more things. There's grid size. Now, grid size means how closely the sensors are placed on your building. So if it's a very small number, and this is where a lot of your computers are going to crash, because if you're working in millimeters and you put something as 2 mm, and your building is several thousand tall, your computer is going to crash immediately. So please check that you're working on meters. This is a pretty tall building. Let's see, 32 meters. That means it's better. I generally like to put something between 2 to 4 meters of sensor spacing. I'll put 3 here or 2 here. I'll take a chance and I'll put a 2 meter grid spacing. Again, make sure that you're working with meters. Make sure this is working with meters. If you put 2 here, blankly copying from my code, and you're working on millimeters, and your building is pretty much the actual size, this is going to crash. Okay, so 2 millimeters. And finally, offset distance. Offset distance means that if this is the surface of my building, I want the calculation to be done slightly above. Because if it's right on the surface, the point is invalid, because it can mean that the point is also inside the surface where there is no sun, because inside all these volumes there is no sun. So it can get pretty erratic. So I'm going to put the smallest number I can think of here, which makes sense, which is, let's say, 5 mm, 2 mm, 1 mm, anything a little above your actual surface. That's your offset distance. Okay. And finally, everything else is irrelevant. I'm going to run. So this is Boolean toggle. So the moment I do this and I run it, you're going to see some error here. Let's see what's happening. There is some issue. Let's realize the error was this. This was not capped, so I'm going to cap it. Make sure that this is sort of a closed box, and I will clear this and I'll feed this again. Okay, and I have hidden everything else for now, but you can actually end up showing it. That's okay. I'll hide this, in fact, if you want to, and you can see that this is perfect. Now if I run it, you are going to get this glitchy sort of this surface. Again, I can also hide the reference geometry, which is Control Q, and you can get this as the data. Now this makes sense because at 1 o'clock in those hotter months, everything else is sort of blue, but your surrounding buildings are sort of shading, and the sun is at the top. So you can see that if I change this, uh, let's say from this is just the morning. What I'm going to do is I'm going to delete this, which means it's going to consider the entire day and not just 1 o'clock. If I delete this, it's going to take some time, but you can see that now the value is a little different, but the entire day means it's also calculating your with twilight hours and in the night. So I'm going to put 6 a.m., which is the starting hour, and the evening, which is 18, which is 6 p.m. So end hour. And all the days of months 3 to 7, that is from March to July. So you can see that this is happening. And one thing to note is we're looking at the total. This is a huge building, and you can see that it's 1.31 into 10 raised to the power 6 kilowatt hours. This is the total solar energy. And most of the times when we are orienting, we're trying to self shade. So what we're trying to do here is uh, we will how this will help is if I, let's say, rotate this by 10 degrees, I will get a different number. See the number reduced. If I rotate to even more, I get slightly more or slightly less. So what I'm trying to do is I'm trying to cell shade as much as possible so that I reduce this value. If I have to actually just give you a quick, if I have, let's say, high rise here, and I also feed that into my reference context, you will see that this will turn blue in a bit, right? So this is further reducing, but of course you can't add a building to shade your building. But that what I'm trying to do here is when you're massing, when you're trying to do conceptual uh, visualization and you're trying to do master planning, orientation, massing, this is really helpful because you have a bunch of blocks, and then to orient those blocks, the idea is to minimize the incident solar radiation so that they can all shade each other and your solar energy or solar radiation is reduced. So hope this makes sense. This is a very powerful tool, and I've only touched the tip of the iceberg. There is ways to get to windrows, wind profile, and there are multiple things. The moment you download pollination, you also download honeybee, which is a whole new dinosaur in itself. So yeah, this is the basic tool, the basic algorithm, basic script, and you can get these cool visualizations. You can always bake this mesh and get this thing out into uh, sort of a rendered tool, right? So it kind of really helps get this data out there.